The random variable x has MGF m. Which of the following is the MGF of some random variable? Okay, you're given this 1, 2, and 3. All right. Now, let's review a few properties of MGF that will help us solving this problem. First is that if x and y are random variables, then MGF of x plus y is the product of the two MGFs of x and y. So MGF of the sum equals the product of the individual MGFs. Second is that if m of t is the MGF of x, then m of at is the MGF of ax. Third is if m of t is an MGF, then m of 0 is always 1. So this can be seen as follows. If x is a discrete variable, then we know that MGF of x is the summation of e power tx f of x. And when t is equal to 0, so mx0 will be e power 0 times x, f of x. So e to the 0x is just 1. So summation of f of x is 1 because we are summing over all values of x. And f of x is the PDF, is the probability function, discrete variable, and all the values of the probability function sum to 1. Now, if x was a continuous variable, then m of mxt would be the integral of e power tx against f of x. And mx of 0, again substitute 0 for t, e power 0 x is just 1. So you're integrating all of the PDF over negative infinity to infinity, and that's always 1. And then the fourth property is that if y is equal to 1 always, then the PDF of y, and then the MGF of y is e to the t. This can be seen as follows. So y is equal to 1 means that y is a discrete variable which always takes value 1, which means it takes value 1 with probability 1 and it doesn't take any other value. So f of 1 is 1. And myt is the summation of ety f of y, and y just takes the value 1. So it'd be e to the t to the 1, e power t times 1 times f of 1, and e to the t, because 1 times t is t, and f of 1 is 1, so that's just t to the t. So now these four properties will help us solve this problem. So now we go back. The first one is mt m5t. So now property 2 tells us that m of 5t is the MGF of 5x. So m of 5t is the MGF of 5x. So let's go down. And then property 1 tells us that the MGF of a sum is the product of the individual MGFs. So therefore, the MGF of x plus 5x will be m of t times m of 5t, because m of t is the MGF of x, and then m of 5t will be the MGF of 5x. So 1 is a valid MGF. Now 2 was saying 2mt. Now this cannot be an MGF because remember, property 3 is telling us that for any MGF, the value at 0 is 1. So if we try to take the value of 2mt at 0, it'd be 2m0. That's 2 times 1, because m of 0 should be 1 since m is an MGF of x. So 2 times 1, and that's 2, and that's not equal to 1. So this means that 2mt cannot be an MGF. So from here we can see that any multiple of an MGF cannot be an MGF because that multiple will take on a non-1 value at 0. So any non-1 multiple of an MGF can never be an MGF. And then the third one was e to the t mt. Now this is an MGF because we just discovered by property 4 that e to the t is the MGF of 1, and therefore and m of t is given to be the MGF of x. So by property 1, 1 plus x will be the MGF. The MGF of 1 plus x will be e to the t, the MGF of 1. times the MGF of x. So the MGF of 1 plus x should be the MGF of 1 times the MGF of x, and MGF of 1 is e to the t by property 4, and MGF of x is mt given. So this one is also a valid MGF. So 1 and 3 are valid MGFs and 2 is not, and that's choice C. That's what choice C was saying, 1 and 3 only. Okay, so